Alright, so let's look at a few more questions. So we want to sketch a solution of this differential equation on this slope field. Now when you sketch a possible solution that passes through one particular point, we just have to follow through the slope field. But one thing that which we have to be careful about is that we shouldn't cut across this slope field. We have to go along with it. So from here, when I look at it, it kind of passes along in this way. So I'm going to have slope field going this way, and here I said it's kind of going down here more, and then it's kind of going down here, following along this one, and then goes up, goes up, goes up, goes up. So that seems to be our first solution. Just make sure that you don't go across. You can touch it, you can go near it, but you cannot go across the slope field. How about the second one? So from here, it seems like it's kind of going down in between this way and going straight. It's going to be going down. Going down this way. Going down and then kind of stops and goes up or something like that. Something along the line. Now this one, I have to go around this way and then kind of comes down and then goes up this way. So I have, it goes up this way and then kind of goes down. And then kind of goes down. Something along the line. Here to the left, it seems like kind of goes up rather rapidly. And then here it kind of slows down. Something along the line. Alright, so for number 31, what they want us to do is they want to fix the left corner and then in a rectangular approximation method. They want us to do 4 rectangles, so then what I have to do is I have to divide this interval by 4. So I'm going to do pi over 2 minus 0 divided by 4, which now becomes pi over 8. So each time I'm going to go up by pi over 8. Now, then if I have to set up a chart, I think it'll be a bit easier for us to do this one. Let me call this one as x, and let me call this one as f. 0, pi over 8, 2 pi over 8, which we know that to be pi over 4, and then 3 pi over 8. Lastly, we have 4 pi over 8, which is equal to pi over 2. For cosine, I know a few values. This one is equal to 1, and then I don't know what this value is. This is pi over 4. Pi over 4 is radical 2 over 2. And then this is pi over 2. For cosine of pi over 2 is equal to 0. So I have to find the other two values here. So I'm going to go Desmos. And then y equals cosine of x. And maybe values here. So I had 0 and then pi over 8 and pi over 4, 3 pi over 8, and then pi over 2. So I'm gonna basically have these values in their location. So I'm going to use these values. So if I were to do LRAM, I'm just going to erase this portion right over here. If I were to fix the left corner, then out of this first rectangle, the left one, meaning the smaller x value, y value for the smaller x value would be our height of the first rectangle. So when I do LRAM, left corner fixed rectangular approximation method, then I know that base will be pi over 8 because it's an equal base. I'll be using the left value 1 plus from the second rectangle I'm going to be using this one. So I'm just going to go for 0.9, the first point, and the next one is plus 0.7, last one is 0.4. So when I add up this way, then this is 1.1, this is 2, so total 3. So we get about 3 pi over 8 becomes our left RAM. How about RRAM? Right corner is fixed. My base is still the same, pi over 8. But my first value will not focus on the smaller x value, y value for the small x value, but we will be fixing the bigger value of the y value. So we're going to get 0.9. Second one is 0.7. Third one is 0.3. And last one is, 0.4. Last one is equal to 0. Then we get to realize that this one is equal to 2, so we get 2 pi over 8. And difference between these two ends up being the pi over 8, approximately. Let's look at the next question. So here, upper and lower sum. Lower sum in this case will be the smaller one underneath, and that happened to be right corner fixed rectangular approximation method. It doesn't always work as a RRAM is always less than the LRAM. Of course, upper one is when the left side is fixed. So when you look at it, what do you realize? Okay, I know that it has interval is 1 to 2, but it has been divided into 5 different pieces. So I know that each one I'm adding 0.2. So according to LRAM, I'm going to multiply by 0.2. That's my base, and then my height, it goes up to 1. Next one is 1 over 1.2 because I'm adding them. Next one is 1 over 1.4 plus 1 over 1.6. 1, 2, 3, and then next one is 1.8. And then when you calculate it, that becomes our upper sums. And then when I do the lower sums, height is the same 0.2, but I'll be starting from this value, which is 1 over 1.2 plus 1 over 1.4 plus 1 over 1.6 plus 1 over 1.8, and then the last number is plus 1 over 2. So that's how we can do the lower sum, which is in this case happen to be RRAM. All right, and then in this case they want you to do the midpoint. And how many interval was it? Actually, and n equals 4. Okay, so when n equals 4, then we're going to do 2 minus 0 divided by 4, which is 0.5. Each time it's going to be increasing by 0.5. Now then my first rectangle, left side is equal to 0, and it's going to be 0.5. But what's my midpoint? Midpoint is 0.25. and the next one is I'm going up by 0.5, so it's going to be 1. But my midpoint will be 0.75. Next one is 1.5. Then midpoint becomes 1.25. Lastly, maybe 1.75. All right, so we have, these are my midpoints. So then therefore, my rectangle will be 0.5, which is my base, times the height. Height is when I plug in 0.25 in place of x. So I get 0.25 squared plus 3 plus 0.75 squared plus 3 plus 1.25 squared plus 3. Lastly, 1.75 squared plus 3. Alright, these becomes, when you add them up, it becomes basically MRAM, midpoint rectangular approximation method. Alright, see you later.